Hello. We're going to determine whether the set of vectors given here, we've got two examples, form a basis for the given space. So first of all, we're going to be taking three vectors in R3. It seems like that would be a good try for our basis because remember, for a basis we need to have the same number of vectors as the dimension of the space. And we know that the dimension of R3 is 3. And we have three vectors. So that's a good start. Now we need to figure out if they're linearly independent. So if our dimension is the same as the number of vectors and they're linearly independent or they span the space, then we are going to have a basis for our space. So I've already entered in the matrix for these vectors. I have a matrix here. If I just use the columns here, sometimes these are given in rows as well. But if they're given in rows, just use the matrix as columns so we can do RREF. We know we like RREF. So I have this matrix entered in my calculator, but I'll show you how it plays out. So I'm going to go to Edit, B, and show you that the matrix is in there. Okay, that looks good. Now, I'm going to quit out of there, go back into matrix, and I'm going to arrow over to math and do an RREF. And my matrix is stored in B. So I arrow down to B, push enter, and this is what I get from my RREF. So I'm going to copy that down. I have a 1, -1, 2, a 0, 0, 0, and a 0, 0, 0. So we know automatically these are not linearly independent. Why? Because we only have one pivot, and for those to be linearly independent we would need all three of the variables to be pivots. So we already know that unfortunately this is not a basis for R3. These are not linearly independent. In fact, if you'd like to, you can actually write a combination of these. For instance, if we said C1 of these plus C2 of these plus C3 of these are equal to 0, and we do look at the REF augmented with 0, what we really get are a system of equations C1 minus C2 plus 2 C3 would be equal to 0. C2 and C3, they don't have pivots, so they're free. So from this, you can see that C1 would be equal to, if I add those over and subtract them over respectively, C2 minus 2C3. C2 is free, and C3 is free. So for instance, if you took, let's say C2 is equal to C3 is equal to 1, I'm just letting those equal to 1, then what you could have is C1 is equal to 1 minus 2, C2 is equal to 1, and C3 is equal to 1. So you could say that, well, let's see if I can get some room here. We'll put it over here. I could say 1, or actually -1 of that first vector, plus 1 of the second vector, plus 1 of that third vector, is equal to 0. And of course you can move those around to get a linear combination. Okay, now I'm going to take a look at this second one. In fact, you might want to do this for yourself. So for a minute here, I'm going to have you pause the video and try this one for yourself. All right, go ahead. Okay, if you're ready now, what I'm going to do is I'm going to turn these into vectors, and I'm going to solve it the same way I did for the first one. So I'm going to take all the x squareds and put them here, all the x's and put them there, and all the ones put them there, because P2, this is a basis for P2. All the second degree polynomials would be some constant plus something times x plus something times x squared. So if I look at these vectors, my first vector would be represented as 0, 6, minus 3. My second vector would be represented as 3, 0, 1. And my third vector is going to be represented as negative 1, negative 2 x's, and 1 constant. So I could go ahead and augment that with 0 and do my RREF. So let's see what we get. Okay, so I have this in my calculator. We'll go second matrix, math, REF, and I believe I have this matrix stored as A. Matrix A. So I get this identity matrix. So what that means is I have the identity matrix augmented with 0. So what that means is the only way to get my polynomial would be C1, C2, and C3 is equal to 0. That's what it means when I have these three pivots, right? So I have three vectors, which is the same as the dimension of P2. And from this I can tell that they're linearly independent. And of course that means that they span P2. So yes, so these vectors form a basis for P2. And that's good. So really what this means, if I augment this with any vector over here, so I could have any polynomial and just put the coefficients over here, that these would be pivots and I would only have one representation of these three to give me that third vector. Okay, well I hope this has helped. Thank you. Bye.